What do you say? Okay. So we're listing the president's one class. Okay. So you guys had a bell ringer this morning. Your bell ringer asked you. I'm just still morning in my head. Sure, why not? What is the topmost horizon of soil? Abby. The O horizon. So ironically enough, what does the O horizon stand for? What does O mean? Organic matter, right? So that's where all the stuff falls and dies and then becomes compost and then becomes really nutritionally sound for whatever's going to grow in the soil. What is right below the O horizon? The A horizon. What do we call the A horizon? What do we call it? What's the name for it? Topsoil. What's below the A horizon? The B horizon. What do we call that? Subsoil. What's below the B horizon? The C horizon. What do we call that? What? The substratum. And what's below the C horizon? The R horizon. And what do we call that? Bedrock. So did those layers make sense yesterday when we were talking about those and making our pudding? Yeah? Okay, good. So today, we are going to start learning about soil textures, okay, and the soil types. And this is important for a couple different reasons, but the main thing being that you have to know some different characteristics of your soil to know how you can use it. All right, so if you ever wanted to get a job doing this stuff, you can become a soil scientist, and you can become the person who goes out and surveys land and looks at that stuff for people, right? But if you don't do that still, you're probably going to build a house or want to grow something someday, and you're going to need information that a soil scientist would be able to give you. So when we talk about a soil texture, that's saying like how coarse or how grainy or how fine is that soil. And that determines a lot of things about the soil, like how well will it drain, how well would things grow in it, all that different stuff, right? So if we want to plant a plant, what's the most important thing about a plant surviving? Okay, it needs water. What else does it need to be able to do?
Sunlight and space to grow.
It needs sunlight and it needs, what was the next one?
Space to grow.
It needs space to grow. How does a plant grow?
Its roots.
Its roots? Its roots go into the soil. Very good, Aiden. So when its roots go into the soil, what does it have to do for those roots to be able to grow into the soil? It needs to be able to bring in water and nutrients, but what else? How does it get there? What is it doing? It's growing, but what is it doing to be able to grow bigger? Okay, so I want you to imagine, like you know in Despicable Me, when, have you seen that movie? Yeah, no. You know in Despicable Me when they've got that big like machine thing that has the big drill on the end and it like out into the ground? You know what I'm talking about? So basically imagine that there's one of those doodads at the end of every part of the plant root, right? And it's going and trying to push its way through the ground. It has to displace the soil to be able to grow, right? It can't just exist. Like if I want to be sitting exactly where Lena is sitting right now, like I can't just be where she is without her moving, right? Anybody argue with that? I can't be taking up the exact same space she is right now without her moving. So the roots have to do the same thing. They have to be able to push through that soil, and they have to move the soil out of the way to be able to move. So if the soil particles are really tiny, then they're going to fit together really closely, and there's not going to be a lot of space in between them, right? Okay, that's how that works. So it's going to be harder because they're so tight for those roots to push through that soil. Now, if they're really big sections, then they can't sit as close together. They can't sit as tight together, right? And then it's easier to kind of break them apart, move them out of the way. How many of you have tried to walk through the hallway where there's a ton of people in it? Yeah, is it easy? No, you gotta like barrel your head and like run through it, right? So versus if there's like 3 people in the hallway, it's pretty easy. Yeah, because they're not as tight together. They're not as squeezed together. So it's easier to get through. And the roots have to do the same thing if we want to plant something. Now I want to paint a different picture for you. How many of you plan to live in a house someday? Yeah, okay. So when you go to build a house, how many of you want together, if roots can't move through it, what's the other thing that's probably gonna have trouble moving through it? Water, right? So if it's really, really tight together, because it's all really, really tiny particles that fit really, really tight together, and the water can't get through the soil, what's gonna happen? It's not gonna be able to move through, it's gonna flood, and it's not gonna be able to move through the basement, right? So you're gonna get a basement that's full of water. How many of you have ever gotten a ton of rain, and then your dad gets all grumpy, he's like, the basement's flooded, I have to go put in a sub pump and empty out the basement. Or is that just my dad? That's just Larry and his dad not gonna. Yeah, some of your parents get really, really angry when the basement floods and then they go plug in the sump pump and get the water out of the basement. And that's because you probably have a type of soil around your basement that doesn't drain very well, or you don't have the right drainage stuff in that, like a drainage pipe or a tile or something that helps get that water out of the way. Hi. Yeah. So unless you have one of those tiles, your basement's gonna fill with water, right? So these are all things that you guys are going to do someday, and knowing how this works with your soil is gonna help explain not to build in a floodplain, right? So we're gonna talk about soil textures. So in your book on that next page from where we were yesterday, where we drew the horizons and stuff, there is a page. Oh wait, we're gonna skip a couple. Yeah, sorry, 76 is great. So we're gonna be on page 76, and you are going to write down that there are 3 different soil particle types, okay? And that is sand, silt, and clay. So all soil is 100% either sand, silt, or clay. All right, it is some makeup of that, right? There's nothing else that makes up your soil other than sand, silt, and clay, okay? Sand is your, or silt, sorry, but you should have written that backwards. I apologize. 1, 2, 3 would be clay, silt, sand. Clay is your smallest particle, and that is 0 to 0.002 millimeters, okay? How big is a millimeter? Like this big, right? So anything that is smaller than 1,000ths of that is the size of clay. So you can't even feel clay when it's between your fingers and you rub your fingers together. You can't even really feel the particles. Silt is 0.002, so anything bigger than clay, to 0.05. So that's still 5/100ths of a millimeter, which is like this big, right? It's still really stinking tiny. And then sand is 0.05 to 2 millimeters. Okay. So I need 3 volunteers. Melena, Journey, and Zayden. Come on up. Journey, stay right there. Please. Okay, sit here. Baby, sit here. Okay. Journey, take your hands. Make a beach ball. Really big. As big as you can possibly make it. Hold it. Okay, great. Thanks. Elena, catch. Okay, great. Good, good, good. Zayden, catch. Okay, cool. Yep, good. So, if we were going to compare, we were going to take these particle sizes, sand, salt, clay, and we're going to blow them up and make them really, really, really huge. Okay? And we're going to make them like a gazillion times their actual size. Make it bigger. Journey would be like a beach ball. I don't have a beach ball, sorry. But Journey the beach ball would be about a sand particle. Okay? Elena's frisbee would be about a silt particle. So hold that up to the sand and see the size difference. You see how it's not even like comparable, like it's so tiny, right? And then Zayden's little golf ball over here would be the clay. So they'll hold that up to Journey's beach ball. Yeah. So that's like if we grew it to scale, but like a lot, that's how big they would be. Does that help you size figure that out? All right, you two can go sit down. You keep holding it right there. Okay, so those are your particle sizes. And then we characterize our soil based on what percentages of sand, silt, and clay it has, and different particles. So if it's a type of soil that has more clay, And my question is that something that you would want to build a house on? You want to build a house on the beach? Why? Huh?
It's not very solid.
It's not very solid. So the second something comes, if you've ever walked on the sand, as soon as you step on it, it like moves, right? Like footprints. Okay. So the second that you step on it, or if you put a house on it, it's just gonna like move, and then your house is gonna like float away, right? So you want to know what type of soil you have. You want to know what type of soil that you have, so that you can figure out what you need to do with it to be successful in whatever project that you have. Cool.
Cool.
We like this?
Am I good?
What?
Am I good?
Yeah, you were good a long time ago. I just wanted to see how long you do without asking questions. Okay, so today we are going to learn how to use what's called the textural triangle. Okay, and this is kind of more like the scientific side of this. After this week, we're going to learn how to texture soil using the ribbon method, which is by like holding it, okay, and feeling it. And then we're also going to learn another method of figuring out the texture as well. So we're going to do this today, and then tomorrow and Thursday, you guys are going to have time to practice using the textural triangle. Cool? The one thing that I do need from all of you is before the end of the week, so before Friday, I need you to bring in a jar of soil. Okay, so you're gonna go out in your yard. You're not gonna get the grass and stuff. You're gonna dig down just past that. But I need a clear, sealable, not a bag, a clear, solid, sealable container about 2/3 of the way with soil in it. Actually, all the way full with soil in it. Okay, so like a mason jar. If you have a plastic, like a mayonnaise or a peanut butter jar, something like that, you take the label off. Something that you can put it in, seal the top. Don't include like the grass and stuff, but get like the topsoil, so like the top foot. Okay, I need you to bring that in by Friday. Can you do that? Cool. So we're gonna learn how to use the textural triangle today. Within the textural triangle, it has all the different classifications of what soil could be called. So you have clay, silty clay, loam, silt, loam, sand, loamy sand, sand, loam, sandy clay, loam, and sandy clay. So one of these is going to be your soil texture classification. And then once you have that information, you say, okay, my house is on a clay loam. Then that person can give you recommendations as to, okay, I want to build a house here. Before you do that, you need to install a tile, which is basically like a ceramic pipe, which is going to direct water away from wherever you're trying to be. It helps the water get away faster since it doesn't leach through the soil that way. Does that make sense? Yeah. Okay. If it doesn't, tell me. So the way that this works is one side of the triangle represents clay, one side of the triangle represents silt, and one side of the triangle represents sand. Okay? And they have a scale on them 10 to 100, or 0 to 100. So that's the percentage that they are in your soil. And then the way that you plug them in, if you look, this is kind of like a three-way grid. Okay? So your clay utilizes the lines that are all straight across. That's the only one that clay concerns itself with. Okay? Your silt works at a downward angle. Okay? So it's only concerning itself with the ones that are pointing down and to the left. Okay? And then your sand works at an upward angle, so it's only concerning itself with the ones that are up and to the left. Kind of like NASCAR, you only go left. Okay? Get me? So we're going to see kind of how this works. If I gave you clay, silt, and sand, which is what all of our soil is made up of, and on that first one there on that bottom of the page, let's do a sample. Let's say that clay is 45%. No. Clay is 30%. Silt is 20%, and sand is 50%. Okay. What do you notice about those numbers? They all add up to 100. If your percentages do not equal 100, you will not be able to figure out the soil type. Okay, it's an inaccurate count. It's not right information. Okay. So if we do this on the clay side, we're going to go to 30. So here's the 30 line. I'm going to put a dot right there on 30 on the edge of that, okay? My silt is at 20%, so I'm going to go to the 20 line on the silt side, and I'm going to put a dot. And then my sand is 50%, so on the sand line, I'm going to go to 50%, and I'm going to put a dot. And since we know what directions we always go, 30, I'm going to go ahead and draw lines that go all the way across that horizontal line that clay uses. Okay. Still, we go down to the left, so I'm going to follow that percentage on that line. In sand, we go up and to the left, so I'm going to follow that percentage on that line. What do you notice? They add up to 100%. What do you notice about the triangle? Yeah, they all cross each other, right? So where they all cross each other is then what your soil texture classification would be. So this soil with 30% clay, 20% silt, and 50% sand, we would call what? Sandy clay loam, because it's right in that box. Does that make sense? Yes with me? Okay, so let's do a couple more and kind of try some different things. So if we said that clay was 25, silt or sand was 15, and you guys, there's other triangles in this book too, so feel free if you get really crowded on one to like flip and use the other ones too. Silt then would have to be 60. Okay. So on clay, we're going to go to 25. On silt, we're going to go to 60. And on sand, we're going to go to 15. Okay. Clay goes all the way across. Silt goes down to the left. Okay. Sand goes up and to the left. What type of soil do we have? Silt loam. Okay, because that's where those lines intersect. Do you guys have questions about this? Does it make pretty good sense to you? If not, totally tell me and we'll adjust. Okay, so let's do one more. Actually, let's do two more. Let's put clay at 30%. Put sand at 45, and that would mean that silt would need to be 25. Okay, so plug that one in and see what you guys get. So clay is 30. Silt is 25. And sand is 45. Go ahead and do that one before I do it on the board and tell me what you guys get as your soil classification. What'd you guys get? Huh? Sandy clay loam? What'd you get? Clay loam? Anybody else? What did we get?
I got clay loam, but I can't really see the numbers, so I just.
Okay, you got clay loam?
I did the wrong one.
Anybody else do something different? So if we draw across here, we draw down here, and we draw up here. Who got sandy clay loam? It's what? It's like right in the middle. Okay. So with these examples and the ones that you're going to practice tomorrow, some of them might hit right on the line. Okay. And so that really on these ones, it is kind of designer's choice, whichever one you want to do, if you want to go to clay loam or sandy clay loam. But I'll tell you why this would never happen in real life. Okay. Because if I took a soil sample and I sent it to the actual lab, right, and they actually analyzed it and told me to the exact what percentage each of these things were, I'm probably going to get numbers back that look like this. Right, I'm going to get ones from a soil lab that have a whole bunch of exact numbers. It's going to be like to the T, right? So in this case, if we're right on the line and we have 45, and that's the exact line, is if it's 45.7, it's going to be a hair to this side, right? And if it's clay and it's 30.25, it's going to be just a hair to this side, right? So because it would be just a hair to this side on sand, we can say that that's sandy clay loam because there's a little bit of a decimal there, right? You're not going to get an exact round number that's going to put you on a line like that in real life. Does that make sense? Okay. So we're going to try one more, and then you guys got this really quick. So, let's say clay is 35, silt is 35, and sand is 25. Go ahead and plug those in. What do we get? Oh. What do we get? Plain loam, are you sure? Maybe? What do you get, Zay? By silt clay loam? Okay.
I can't see the number.
What do we get? Plain loam? Is there anything weird about this one? The points don't match up. Why not? Oh, that's right.
Oh.
So, if it is not equal to 100, your points will not line up and you cannot dial down. Now, this one you probably could because all of the points are within clay loam, so if you got it right, you're probably, even if it's weighed, unless it's weighed up a little bit, then you might get in the clay. But since you do not have accurate percentages, because everything will be sand, silt, or clay, you cannot identify the soil. Okay, so. Couple sense? Yeah. Or are you saying the same as well? You're crazy little. Why are you making us draw on triangles? Or you're saying go? Yeah. Yeah. Okay. Perfect. So, sand, silt, and clay are your only soil particles. Like I said, next week-ish, we're gonna do a couple different things. We're gonna learn how to ribbon, where we're gonna actually like rub like dirt in our hands, and then we're gonna be able to like tell what soil it is, right? And we're going to do something with the jars that you're gonna bring in, and we're gonna eat some snacks, and we're gonna do some different things that's gonna help us learn just a little bit more about soil texture. But that's why it's important to understand what soil texture you have. And actually, at the end of this, we're going to figure out what soil some of you guys do have at your houses, and you might be able to pinpoint why you have different types of effects on your land and stuff like that because of what soil type you have.
Called it dirt.
Did I say dirt?
Dirt.
Yeah.
Yeah, and then you told us we weren't supposed to say dirt.
I did it to test you.
Stop.
Ah.
I don't want to just yell.
Do you guys have questions about this or the horizons?
No.
All right, tomorrow I'm just going to show it to you. If you're over, well, I'm going to give you guys, because I'll tell you what, you guys got through this about a lot faster than the other class did. So I'm going to give you guys some free time here at the end of class. But tomorrow, when you're in here with this stuff, if you're not told, you guys have a little more time with me. So on 83 and 82 and 83, there's 15 different questions there. So you'll solve those using, and you can use all the textual triangles to either side too. All right, but you're just gonna answer those. The first ones have all the percentages. The last half of them, you have to find the missing percentage and then plug it in. So you just add, subtract that from 100. Is that cool?